This video serves to demonstrate the use case 3 of the mF2C project. This use case implements a smart fog hub in airport. During the first part of the project, this has been simulated in a test lab, while in the final release it will be implemented at the Cagliari airport. This first look shows the part of the engineering campus that has been dedicated to simulate part of the lounge of an airport, so an open space with a high concentration of connected objects, so travelers that move freely in the field and get advised on shops or services nearby their position. The system architecture implemented in this phase is a 3-layers architecture, plus the IoT layer. The first layer is made on cloud, with some VMs on the OpenStack cloud infrastructure managed by engineering, which is used for heavy processing, data synchronization, historical data management and dashboard support. The fog layer is split into 2 parts. In the first we have a Nuvlebox Mini with 8 GB of memory. It's an appliance specifically designed to be deployed in open spaces, providing a cloud-in-a-box solution with high virtualization capabilities. It acts as fog leader, running the mF2C agent, managing operations in real-time, aggregating the data received from the layers below. The second fog layer is made by a laptop that acts as fog node, running the mF2C agent, performing real-time proximity calculations, with processing distribution to other nodes in case of need. In the IoT layer we have 4 Raspberry Pi that provide good computing power and good communication features with low latency and indoor spaces. These have been placed at the 4 vertices of the environment and act as access control nodes. At the moment do not run the mF2C agent. Through their Wi-Fi signal strength, the smartphones can calculate their position in the space and are being tracked. In the environment, some points of interest have been configured, corresponding to useful shops or services. Here we have configured an information office, a restaurant, a bar and a perfumery. At the edge level, the smartphones of travelers currently do not support the mF2C agent. They install and run an Android mobile app through which they interact with the system. The traveler need to download and install the app. Then running it, he need to read and accept the privacy policy on personal data treatment in accordance with GDPR law to continue. Then the smartphone establish a secure communication with the nearest access node, calculates its own position and continuously requires the proximity calculation. An interactive map with the layout of the engineering campus is presented, integrated in Google Maps, to facilitate the indoor navigation. It represents the current position of the smartphone in the map and configured points of interest. In order to use the app in the most proficient way, the traveler needs to select the Topics tab and select the topics of interest. In this case, its own flight and a topic related to international food. In this way he will notify for all relevant events of his flight and the selected topic. Then the traveler can move freely in the field, being tracked and notified in case of points of interest nearby with appropriate messaging. Moving towards some point of interest, the traveler get notified. In this case the user is informed of being close to the tourist information, and get aware of a promotion on the restaurant. Then moving in the other direction, the user get closer to another point of interest, the restaurant. Here we get closer to the restaurant. The notification tab inform the traveler about the proximity to the restaurant, but also about the promotional message on a discount on Japanese food. Then the traveler continue moving in the lounge and get closer to the third configured point of interest, in this case a perfumery, when notified about the proximity. In the tab, the user gets also the alert about the flight call of the selected flight, inviting the traveler to move close to the gate. In some cases, the traveler could be notified about proximity to several points of interest. In the screen there are also two windows showing the logs related to the mF2C agent in the upper side, and the application logs in the lower side. Calls are made from the application to the mF2C agent. From the text we highlight that some points of interest are recognized and notified in the appropriate tab. Finally, we can have a look at the window that shows the dashboard, that collects information from the fog nodes and cloud for real-time and historical data, and represents the back-end perspective of this use case. Here are the various points of interest can be configured, together with the promotions for shops, and full monitoring of the field is performed. Here blue spots represent the active devices in the field. Green spots represent the access control nodes, while the red spots represent the points of interest. Selecting the History tab, the various information on session history has been shown. While selecting the Heat Map tab, the layout of the field is shown, presenting the summary of sessions archived so far, coloring the most visited points, so giving way to determine most frequent paths and behaviors of the travelers. For more information on this use case or the mF2C project, please visit our website. Many thanks.